Welcome, everyone. If you want to write who you are, where you're calling in from today in the chat, we'd love to hear from you and see who's with us today. Hi, Tovo. Hi, Sung Young. Thank you for joining us. Hi, Judy. Hi, Kate. Hi, Joe from Sheffield. I'm in Nottingham, so not far from you. Hi, Ingrid. Okay, so thank you to my colleague Irina Hope from the RDA, who's going to be with us admitting people as they come in today. I think in the interest of time, I can get started, and I'd like to start by saying good morning, good afternoon, good evening, everybody, depending where in the world you are joining us from today. Great to see so many of you here. And thank you very much for joining our first online information session, where we're hoping to explore in more detail the topic of agentic AI, and hopefully with the help of our speakers and the discussion, start to answer this question: what is agentic AI? And I'm sure some of you here already have some thoughts on that. So this work is part of the RDA's global agentic AI initiative. We started work on it on the end of last year. We have this information session today, and then we also have a follow-up information session on Thursday, where we have different speakers that will be talking about slightly different things. But although these sessions are actually run in the context of the RDA's virtual 26th plenary, they're actually open to anybody who's interested. So if you want to join us again on Thursday, or the events that are taking place also next week, please feel free to do that. To introduce myself, my name is Connie Clare. I'm the RDA Global Community Development Manager. My contact details are shared in the chat, but I'll also make sure that I share these slides and our speaker slides also with you via email, so you'll have access to the information and the links also after the session. So just a bit of housekeeping before we begin. This session is being recorded and the presentations will be published on the RDA web platform. So just please mute yourself if you're not speaking to minimize any background noise. We do like to see your faces in the RDA, so if you're willing to keep cameras on during the discussion, we'd welcome that. Just to let you know that this is an RDA organised event, so we will be adhering to the RDA's Code of Conduct. Please can I just remind you to listen openly and respect all of the perspectives shared today. We will be hearing from two international speakers, and there will be some time for Q&A at the end of the session. So if you'd like to write your questions in the chat throughout, we'll try to get round as many of those as possible. If you do have any questions or comments about the work that we're doing currently on the RDA, on the AI and agentic AI, you can reach out to me, and you can also contact the RDA Secretary General, Hilary Hanaho, who's on this call, and her email address is also being shared in the chat as well. So today's agenda, I'm going to get us started by giving you a bit of background on the global community consultation on agentic AI in research. Then I'll hand over to our first speaker for today's session. Both actually our speakers are active RDA members, but Natalie Mayers will talk about a new lens, 4 different archetypes or roles of embedded intelligence. And then I'll hand over for our next speaker, who is Saeed Chowdhury, who will talk about a new type of evaluation and how we evaluate agentic AI models. And then hopefully we'll have time to have a discussion. You can ask the speakers some questions, and then we'll close for closing remarks and next steps. So for those of you who might not know the RDA, welcome. To the RDA. We are an international member-based organisation comprising more than 16,500 members spanning more than 150 different countries. And we have this common shared vision and mission that our community members come together to openly share and reuse data across technologies, disciplines, and countries to address the grand challenges of society. And our mission is that the community works to building the social and technical bridges that enable open sharing and reuse of data. And at the heart of everything that we do at the Research Data Alliance are our 6 guiding principles of openness, consensus, inclusivity, harmonization. We are community driven and non-profit and technology neutral, which means that all of the work that is produced by the community is importantly openly available for adoption and reuse by anyone anywhere in the world. And if you're not yet a member of the Research Data Alliance, I'd just like to remind you that it's open and free for anybody interested who adheres to our vision, mission, and guiding principles to get involved. So the work that we've been doing more officially on artificial intelligence within the Secretariat has really started around 2 years ago, and we've done a series of different projects and initiatives and events, and we do have a dedicated web page which shows all of those activities, as well as the reports, the white papers, the slides, and the recordings for our past events and also any upcoming events that you might attend. We also have a section on that webpage where we have a showcase of community experts. So these are the fantastic individuals who have contributed to the work that we've been doing in artificial intelligence. You'll also be able to read about future work and how to get involved, as well as any interesting or relevant RDA groups that you might like to join. So I just want to signpost that webpage for you to have a look at. And the work that we started on Agentic AI started in November 2025 in collaboration with one of our organizational members, Microsoft, who have a mutual interest in this particular area. So in November, we ran a global community consultation on Agentic AI in research. We understand that AI agents, or the term, is becoming more commonplace, somewhat of a buzzword that you might be hearing in different contexts. We appreciate that agents can autonomously assist with different tasks throughout the research lifecycle, from data analysis through to data publication, research evaluation and impact. The idea is they could possibly accelerate or speed up research, reduce costs, and provide access to tools that might not otherwise be available. So we ran 4 online information sessions and had a survey open for a month to find out a bit more about how the community is currently using Agentic AI, if they are. What are the needs or challenges that might exist? And where could, or possibly more importantly, how could Agentic AI have the greatest impact throughout the research lifecycle? And we took into consideration the different perspectives that were shared in the sessions and also through the online survey, and we drafted an open report, which I'll share on the next slide. And the next phase of work, which we're hoping to start pretty soon after the plenary actually, is to work on an open technology agnostic blueprint for a priority AI agent. And I'll come back to that in a couple of slides' time. So here is the report, and my colleague Irina will also share a link in the chat. It's published on Zenodo, and I would encourage you to have a look at that to read more about the different perspectives and the global community priorities for agentic AI in research. So what is agentic AI? And that is the question, of course, for this particular information session. And you might think, why am I asking this question? And I'm going to share a definition here on the slide. But I just want to say that this is a working definition that we used for the particular consultation. However, we do recognise that you as community members and experts probably have different definitions and perceptions and notions of what an AI agent means. So if you do, please also share that in the chat, and we'll hopefully come back to that in the discussion. But for the consultation, we settled with the definition that agentic AI refers to artificial intelligence systems that possess autonomy, goal-directed reasoning, and the ability to act independently with minimal human oversight. So the idea that a series of different tasks could be executed within a pipeline without human intervention. And this is in contrast to traditional AI models that we might know that respond directly to prompts. And I'm sure our speakers will have something to add to this and say as well during the session. So what did we do in the consultation? As I mentioned, we had these information sessions, we had the survey, and we received 83 responses from 25 different countries. The largest group of respondents were researchers and scientists. The vast majority had used AI and machine learning tools before, but more than half had not used agentic systems specifically, or maybe didn't know about them. Now, in the survey, we proposed 11 conceptual tools. So just to note that these are not under development currently, but they are proposed concepts that were actually identified during a previous engagement between Microsoft and over 50 institutions within the UK. And in the survey, what we did was we pitched these tools and we gave a definition of features and functionalities that might possibly be relevant for these tools. And we asked the community to tell us whether they were very useful or not useful at all, so score them in some way. And this is the ranking that you can see. It was a weighted scoring system. And you can see that the top 3 priority tools were the literature librarian, followed by the data director, also followed by the funding finder. And you can see the most least popular or lowest priority tools were the collaboration catalyst, publication preparer, and ethics reviewer. So this is a bit of a busy slide, but it just shows you in the center the research life cycle, where you can see the generation of a hypothesis or new research idea through to reporting on research output and impact. And you can see where those 11 tools might possibly slot in throughout the research life cycle. And just to share, the top priority tool, the literature librarian, could possibly help with natural language literature searching, integrating with library subscriptions or contracts to access articles, open access, or behind paywalls. The second priority tool, the data director, could help with automatic metadata creation, ensuring compliance with FAIR or FAIR squared principles, which is specifically for AI, could help with assigning DOIs to datasets, or providing guidance on where data could be archived or published to be compliant. And then finally, the funding finder, which could scan scattered and niche funding databases to match calls with ideas, provide templates for applications, ensuring guidelines are met, and maybe suggest improvements based on previous successful applications from the university. So if you want to read more about the tools and the different functionalities and features that might be present, you can read through the report. So just share that. So I'm going to come back to the high-level agentic AI now, and I'm going to pose this question again. What is agentic AI? And why are we here having this discussion today when we want to work towards the development of a blueprint? Well, I'll come back to this concept that there is a definitional instability. We're still not quite clear on what agentic AI really means. There was some unfamiliarity among respondents when we undertook the survey. The vast majority are unsure whether they've used agentic AI or they might not have used agentic AI before. And when we asked them to score tools based on usefulness, there were still a large amount of people saying they're unsure as to whether this tool would be useful, possibly because they have insufficient knowledge or experience of working with AI and AI agents. Across many different tools, there was also confusion between agents and the chatbots, LLMs, the Claudes and ChatGPTs that we use today. And many also questioned whether agentic AI is necessary for some of these tasks. One respondent said that, for example, a funding finder, we don't need an agent, a well-organized database and search engine could suffice. Others said that also standard chain of thought LLMs with retrieval augmented generation and retrieving sources from external sources is enough. So we don't need agents. And so this was important, I thought, to open the floor and have a discussion with the community and to discuss what agentic AI is. And so on that note, without further ado, I'd like to hand over to our first speaker for the session, Natalie Mayers. And Natalie serves as an AI researcher in residence at the Association of Research Libraries and Coalition for Networked Information in the US. And Natalie's talk will explore a bit more about what agentic AI is and how this works in practice. And we'll actually share a framework that categorizes AI into 4 different roles: augmenting human decisions, automating processes, orchestrating autonomous agents, and explaining outputs. So I will stop sharing, Natalie, and the floor is yours. Thank you very much for being with us today.
Thank you, Connie. Hopefully you can see my screen. It's a pleasure to see all of you here today. And I'd like for us to start with a story or two. Connie's going to paste a link into your chat from a paper about how an AI agent freed itself and secretly started mining crypto. And I'm not just sharing this story with you to shock you. I'm sharing this story because the team who wrote the scholarly paper about it, Agentic Crafting on Rock and Roll, got to troubleshoot something unexpected when an agent broke out of their sandbox that they were working in and started trying to mine crypto. The way they observed this and how they report it in the paper have lessons for us all. Connie, if you could paste those in, that'd be awesome. There's also another link to a story I saw that I think will be interesting for you to think about in the context of what is an agent. And that is the story of Dan Bottero, head of engineering at Anon. They were a company working on authentication for agents. They had created an OpenClaw agent, Octavius Fabrius, to test their technology. And Octavius famously ended up applying for 278 jobs. Here's a link for that one too. What's interesting about this situation with Octavius is we think about AI displacing humans for jobs, not actually competing them with them directly by online application. So that's definitely a case of an agent acting on its own. And these set the stage for how we think about the roles that scientists wish AI could play on their projects. And there's a paper called Artificial Intelligence and Illusions of Understanding in Scientific Research by Messeri and Crockett, where they observed that the proliferation of AI tools in science risks introducing a phase of scientific inquiry in which we produce more but potentially understand less. And this paper came to my attention through some work of colleagues of mine, Chuck Vardaman and Don Brower. We'll learn more about their work in a second. But I thought in reading this that we can use these roles and archetypes to better ground our own thinking about what we want from AI agents. Connie is sharing the link to that Messeri and Crockett paper. And what I like about this is that by analyzing the appeal of these tools to scientists, agentic AI tools and AI generally, what Messeri and Crockett do is begin to use those to provide a framework for advancing our own discussions of responsible knowledge production in the age of AI. They do this through a discussion of 4 characteristic roles. They call these visions. They are the oracle, you can see that on the screen, the quant, and the arbiter. The oracle is a summarizer, a hypothesis generator. It can digest vast literature to provide candidate insights. That kind of maps to our own notion of the lit agent. They also identify a surrogate or digital twin in our parlance. That replaces data obtained via instrumented observations, sensors, or full physics-based simulations with AI-derived data to emulate similar informational content at substantially lower cost or latency compared to the collecting the data, and can be really useful in use cases like small patient populations that are difficult otherwise to analyze at scale. The quant is an AI role that performs large-scale data analysis, parsing patterns across massive data sets. And the arbiter is an AI that evaluates or judges, helps scientists triage manuscripts to flag reproducibility concerns. Messeri and Crockett go on to describe the risks that accompany scientists' desire for AI to perform these roles. One, for the oracle, is illusion of explanatory depth. Oracle systems can produce an illusion of explanatory depth because they're fluent, but they might give shallow answers that feel convincing but aren't grounded. Surrogates can produce an illusion of adequacy. They can overfit to proxies and produce illusions where models appear valid but miss essential variables. Quants can drift into a monoculture of measurement where only what is easily quantifiable gets studied. And lastly, arbiters can create illusions of objectivity where algorithmic decisions mask assumptions baked into training data or evaluation criteria. And you're going to hear more about evaluation of models themselves from Saeed in a moment. So where do these roles take us? Where Masseri and Crockett focused on what scientists imagine AI to be, my colleagues Don Brower and Chuck Vardaman at University of Notre Dame took up Masseri and Crockett's work and they extended it to 4 archetypes that describe how data and computationally intensive projects could implement AI responsibly in cyber infrastructure. Connie will share a link to that in the chat. And what Brower and Vardaman did was introduce these 4 archetypes: augmented intelligence, automated processing, agentic orchestration, and explanatory intelligence to map naturally onto the stages of the National Science Foundation Major Facilities Data Lifecycle. They were working in the context of the FAIR for Large Instrument Facilities Working Group, and this was really important to them of thinking about where do AI agents and AI tools not only fit into the science lifecycle we saw in Connie's slide, but also to our tech stacks and the way that we do information flows through those. Together, Masseri and Crockett's roles show us what's desired. Vardaman and Brower's archetypes show us essentially maybe how we could deliver it. And Masseri and Crockett's risks remind us of what must be avoided if AI is to remain trustworthy. Here, a graphic Chuck Vardaman made illustrates the intelligence plane that could help us understand model activity in agent governance in the context of the research lifecycle and our tech stacks. In his presentation at the AI Meets CI, Intelligent Infrastructure for Major and Mid-Scale Facilities, what Chuck pointed out was that the AI imperative for major facilities was not about adding new tools per se. It was about building a governed explanatory infrastructure where humans and machines could reason together, ensuring that the acceleration of discovery never comes at the cost of understanding. And I think we can all agree that's a great direction to head in. So here we see a proposed intelligence plane where FAIR data, because of its machine actionability, sits at the bottom as a substrate. Its semantic interoperability lends itself to reuse in an AI-rich environment, and AI services and their affordances rapidly become part of the scientific infrastructure we're all using today. But how do we know those AI tools, those AI agents, are operating within the constraints that we want to put upon them? How do we know they're well aligned in disciplinary problem spaces? It's clear from the story we started with about the AI agent mining crypto that we're going to need a layered approach to managing the way we operationalize AI inside our science systems. So I encourage you to use these roles and archetypes to design your own intelligence layer, your own governance layer, and what needs to be in there for you to be confident in how you're implementing AI inside scientific research projects. There's a list in the slides we'll share of the works that have been cited here so you can visit on your own. And I really welcome conversations on this topic in my role as AI researcher. I invite you to connect with me on Whova LinkedIn during the plenary or email. And before I turn it over to Saeed, I'd like to invite you to join the RDA P26 Birds of a Feather session that will examine some of these issues that's going to be held on Wednesday during Breakout 7. Yes, you can still register for the RDA plenary, so hop on over there. This session in particular will be all about autonomous agents. It will feature a demonstration of the NIH IAM-Port platform, which is a foundational data repository facilitating AI-enabled immunology research. We'll also have a panel presentation and question and answer with Nana Barathi from Australian Research Data Commons on AI agent risk and responsible AI, from Lars Eklund on role of agentic AI in the EU data spaces, from Patty Buendina on agents visiting data. She has a cool slide in her talk that shows the increasing autonomy of agents from click-throughs to tools. So I think you'll enjoy her talk a lot. Ronan Piranen will be visiting from Israel on bridging policy and practice and how AI agents can help and not harm. And Francis Crawley will be there introducing the pilot principles for AI governance, herding autonomous agents. And Luis Jacob Rettenon, who is a member of the Armed Forces in the Philippines, will be describing agentic AI use cases in cognitive warfare. So in the Research Data Alliance community, we get the benefit of global perspectives on AI use, on the benefits and potential risks of AI agents. And next, we're going to hear from Saeed, a very active member in RDA, on agent reliability and evaluation. So I hope, like me, this community brings to you different perspectives, and I welcome your conversations in the plenary. Thanks so much, Connie, for everything.
Thank you, Natalie, and thank you for that wonderfully comprehensive talk in that short space of time. And if you have any questions for Natalie, please do add them to the chat. And I'm just going to introduce our next speaker. Saeed, thank you very much for being here. Saeed Chowdhury is the Executive Director of the Open Forum for AI, as well as the Associate Dean for Digital Infrastructure at Carnegie Mellon University in the US. And Saeed's talk will examine why evaluating AI agents on performance alone isn't enough, and explores new efforts to evaluate them based on trust, safety, and accountability, particularly as they become more autonomous. So, Saeed, the floor is yours. Thank you very much.
Thank you, Connie. Let me go ahead and share my slides as well. Hopefully you can see them. So I will be speaking about this recent work that's come out about evaluation of agentic AI. As Connie mentioned, I lead something called the Open Forum for AI, or OFAI. This is led by Carnegie Mellon University, but it is a multi-university, multi-nonprofit program aiming to bend the arc towards more human-centered AI, responsible, transparent, and ethical AI. We have embraced openness as a design principle, particularly as we think of AI becoming a form of infrastructure. This is at the heart of the work of OFAI, is an openness in AI framework. We are developing a socio-technical framework with deep engagement with the community that rigorously defines what openness is, and then ensuing analyses about the benefits or potential risks or costs associated with openness, with a goal toward moving from conversations around open source, which are important, of course, but trying to think more broadly about open governance. So not only the definitional work that's necessary, but a lot of the engineering and policy work that's associated as well. And all of this work has to happen within the context and specific use cases, of course. So I'll begin by affirming probably what many of you, or if all of you, maybe agree or are seeing, is that we've seen a noticeable shift in the premise or idea that you can simply use a large language model and it will evolve into general purpose technology, as has been promised for about 2.5 years, I guess, at this point, maybe longer. That hasn't happened. So I think there are many researchers, many companies, many investors, take your pick in terms of the lens on AI, who are basically saying, clearly that is not the pathway. We need to embrace smaller models and we need to embrace agents. And the authors of this paper, while one of them has an academic appointment, all come from NVIDIA. So this is not some abstract academic viewpoint. This is an industry viewpoint as well. I borrowed this slide from a colleague of mine at Carnegie Mellon, Mike Skierpan, who actually works in AI and ethics. And I attended a workshop last October in DC where there were people who know much more about agents in AI than I do, experts in the field. And we spent the entire morning debating the definition. And by lunchtime, we agreed that we would not arrive at a consensus definition of what is an AI agent. So Connie's point about definitional instability is very much on the mark. I did see something in the comments. I think I'm getting this right. Somebody had commented that an AI agent is sort of specifically for a particular task or a particular use case, particular data, whereas agentic AI is more the framework for the orchestration or interaction of those agents and models and data and so on. And I think that's reasonably accurate. Noting that there wasn't agreement amongst the experts in the room. But the key word to me is autonomous. We've used that before, and I think that is really the most important kind of aspect of these agents that makes them so powerful, but also raises some questions or concerns as well, at least in my mind. So I'm citing some work, and I'll put links into the chat for all these resources once I'm done speaking. This is work that's come out of Princeton most recently. I should note that my first degree is actually in civil engineering. So in the past, I guess I'll put it that way, I have recollection of interacting with physical systems. And my brother is also an engineer, mechanical engineer. He spent his whole life working with physical systems or hardware. And every so often, he and I have this conversation where he says something to the effect of, "You software people, I don't understand," as if I represent all software developers in the world. You released your code to the world, knowing it has bugs, knowing it has issues, and then you just sort of get patches and fixes and so on. You don't do that with a bridge. You don't do that with a car. It's not to say that there isn't some uncertainty and some risk, but the key is that you know the failure modes and you know the probabilities associated with those failure modes. We don't typically do that when it comes to agents, agentic AI, or even LLMs for that matter. So I think the researchers at Princeton are rightly starting to come back to what's called safety engineering or reliability engineering. And I don't think they would disagree with this. I'm not sure that those approaches will seamlessly transfer over into the AI or agentic AI world, but they're at least a good foundation to ask these kinds of questions. They in their blog post make this really interesting point saying we're in a world where a very skilled driver on a perfect weather day drives a car and we assess whether that's the performance, whether that performance is good enough for every outcome. What happens if it rains? What if I'm not a skilled driver? What if the conditions are poor? So on. So the ideas about consistency, predictability, safety, and scaling are really critical. And I don't know that we're doing a really good job of that, to be honest. And that they are attempting to come up with some frameworks and benchmarks to do this. Now, I will point out, I'm involved with an effort out of Carnegie Mellon, co-funded by NIST, called AIMSEC, which is looking at evaluation of the large language models. We don't have clear, consistent agreement about how to evaluate the LLMs themselves. And so I think there's a compounding of the uncertainty, if you will, when you move from the LLMs to agents to agentic AI. And that does cause me some concern. And I think that there are a few questions that are worth asking. So the first was already asked is it necessary to use agentic AI? If you can accomplish the task without using an agent, then by all means, please do so. There's no need to introduce additional risk or additional uncertainty or unpredictability or so on into the mix. The other question I would add, a couple of questions I would add, is the interaction effect. Do you need multiple agents interacting with each other? Can you work with a single agent doing a single task? Do you need those single agents to interact with each other, or can you partition them in some way so that they're not interacting with each other? Can you have pauses, interventions where a human does have to look? That doesn't make it fully autonomous, but maybe that's okay. Another group of private sector researchers at Hugging Face have written a paper, I'll also link, where they say we should not develop fully autonomous agents. That is their conclusion. Hugging Face isn't exactly an anti-AI group in any way. So for them to make that kind of assertion is really eye-opening. The metaphor I often give is prescriptions. If you take prescription drugs and your physician says, here's another medicine you should take, I hope all of us say, well, what about the other medicine I'm taking? Have you checked the interaction effect? And I hope that the pharmacist, upon looking at my record, also might say, hey, there's an interaction effect here. What is the equivalent when it comes to agents? The autonomous question I alluded to, yes, there's a real appeal and a real power to having fully autonomous agents, but we don't have to be binary, right? There can be a spectrum of the degree of review and autonomy, if you will. And then the final question, in my opinion, is who do you trust to do these kinds of evaluations, right? I talked about the role of openness. I think it's fair to say that in some fundamental sense, what we're grappling with is you have large tech companies with the LLMs, increasingly with agents, saying, we do the evaluation, we are being rigorous, and you simply have to trust that what we've done is appropriate. Or do we lean into more of an open approach where we say, no, there ought to be some third party evaluation or some benchmarks, frameworks, common metadata schemas, whatever it might be, that allow others to evaluate this as well. And I say this in the context of the United States, even though I know one of the real benefits of RDA is it's a global community. But the reality is that the large tech companies in the United States are producing these models, with the exception of open source models coming out of other parts of the world like China. In the US, when airplanes started flying, there was no regulation. And it took an accident between two airplanes to suddenly create the Federal Aviation Administration and have regulation and so on. I really hope we don't wait for something catastrophic to happen before we start to ask these questions and address them. So maybe a provocative way to end, but that's where I'll leave it. And hopefully that can generate some conversation for our session. Thank you.
Thank you, Saeed.